In this video, we will be solving part C to part F of question number 3.2. So let's begin. Part C says, what is the slope of Ambrose's indifference curve at the point 9, 8? Hint, recall from calculus the way to calculate the slope of a curve. If you don't know calculus, you will have to draw your diagram carefully and estimate the slope. So before solving this question, let's first learn what do you mean by the slope of indifference curve. The marginal rate of substitution measures the slope of indifference curve. So what do you mean by it graphically? Consider this graph where on the x-axis you have good x1 and on the y-axis you have good x2. And this blue graph is your indifference curve. Now if I want to evaluate the slope of the indifference curve at this point, which is at this black consumption bundle, then I have to draw the tangent at this consumption bundle and estimate the slope of that tangent. So the slope of the tangent at this point will be the slope of indifference curve at this point, or you can say that it will be the marginal rate of substitution at this point, which is something that is being summarized here. So let's apply this concept. Now the question is asking us to find the slope of Ambrose's indifference curve at the point 9, 8. Recalling from your part A, we drew this table where we calculated all these points, and using these points we drew two indifference curve. The blue points corresponds to the blue indifference curve and red point corresponds to red indifference curve. Now the point 9, 8 lies here, which means it will be lying on your blue indifference curve as it is in blue color, which is this, and this is your point 9, 8. And now we have to find the slope of this indifference curve at this very point, which means if I draw the tangent, which is this red line at this point, I have to calculate the slope of this tangent, and the slope of this tangent will be equal to the slope of the indifference curve at the point 9, 8. So let's calculate the slope of the tangent. From your first part, this blue indifference curve had the equation as x2 is equal to 20 minus 4 square root of x1. So in order to calculate slope of this indifference curve, we have to differentiate x2 with respect to x1. So let's do that using the calculus, which will be derivative of x2 with respect to x1, which is nothing but minus 4 divided by 2 square root of x1, which is equal to minus 2 divided by square root of x1, and this is your MRS. Now the question is asking us to calculate the slope of indifference curve at the point 9, 8. So let's evaluate the value of this slope at the point 9, 8. So your slope at 9, 8 is nothing but minus 2 divided by square root of x1 evaluated at the point 9, 8. So all we have to do is here just substitute the value of x1, as this expression is consisting only of x1, and evaluate its value. So let's do that. That would be minus 2 divided by square root of 9, which is minus 2 divided by 3. Thus, the slope of Ambrose's indifference curve at the point 9, 8 is minus 2 divided by 3. So moving on to the next part, it says, what is the slope of indifference curve at the point 4, 12? Now again coming back to this table, point 4, 12 is here, which is in blue color, which means it will be again lying on blue indifference curve. Graphically, it is lying here. If we draw a tangent at this point, which is this red line, the slope of this tangent will be the slope of the indifference curve at the point 4, 12. Now note that in part C, we calculated the general form for the slope of indifference curve having this equation, that is x2 is equal to 20 minus 4 square root of x1, which is this. So that is the slope is equal to minus 2 divided by square root of x1, which is equal to your MRS. So since the point 4, 12 is lying on this blue graph, it will have this equation, that is x2 is equal to 20 minus 4 square root of x1, and it will have this slope which we just calculated. And now the question asks us to evaluate the slope of indifference curve at the point 4, 12. So let's do that. That is slope at 4, 12, which means we have to just evaluate this expression at the point 4, 12. That is minus 2 divided by square root of x1 evaluated at point 4, 12. So let's substitute the value of x1 into this expression as it only consists of x1 and not x2. By doing that, I have minus 2 divided by square root of 4, which is minus 2 divided by 2, which is minus 1. Thus, the slope of indifference curve at the point 4, 12 is minus 1. Moving on to the next part, it says, what is the slope of indifference curve at the point 9, 12 and at point 4, 16. So like previous parts, what we have to do is just figure out the slope of the tangent at that point and we will be able to figure out the slope of the indifference curve at that point. Now we have the point 9, 12. So coming back to the table which we drew in part A, your point 9, 12 is in red color, that is here, which means it will be lying on the red indifference curve. So graphically your point 9, 12 is this black dot where Ambrose is consuming 9 units of nuts and 12 units of berries. In order to evaluate the slope of the indifference curve at this point, we have to draw the tangent at this point, which is this green line, and calculate its slope. Recalling from your part A, your red indifference curve had the equation as x2 is equal to 24 minus 4 square root of x1. So calculating the slope means we have to differentiate x2 with respect to x1. So differentiating x2 with respect to x1, which would be minus 4 divided by 2 square root of x1, or your slope is equal to minus 2 divided by square root of x1, and this is nothing but your MRS, and this is your general form of the slope for this indifference curve. The question is asking us to evaluate the slope at the point 9, 12. So we have slope at 9, 12, which means we have to evaluate this expression at the point 9, 12. So minus 2 divided by square root of x1 at the point 9, 12. So substituting the value of x1 into this expression, it will be minus 2 divided by square root of 9, which is minus 2 divided by 3. Thus, the slope of indifference curve at the point 9, 12 is minus 2 divided by 3. The question also asks us to evaluate the slope at the point 4, 16. The point 4, 16 is again in red color, which means it will be lying on the red indifference curve having this equation. Graphically, your point 4, 16 is lying here on the red indifference curve. And in order to calculate the slope of the indifference curve, let's draw the tangent. We have to find the slope of this green tangent at the point 4, 16. Since the point 4, 16 is lying on the red indifference curve, which is having this equation, and we just calculated the general form of the slope or the MRS of this indifference curve, which is this. So let's evaluate the slope at the point 4, 16. So you have slope at 4, 16. That is evaluating the expression minus 2 divided by square root of x1 at the point 4, 16. So substituting the value of x1 with 4, I have minus 2 divided by square root of 4, which is minus 2 divided by 2, which is equal to minus 1. Thus, the slope of the indifference curve at the point minus 4, 16 is minus 1. Just keep one thing in mind while calculating the slope of indifference curve at any point. First, see where that point is lying, whether it's lying on the blue indifference curve or red indifference curve, because both the indifference curve have different equations. So be very careful with that. Now moving on to the next part, it says, do the indifference curve you have drawn for Ambrose exhibit diminishing marginal rate of substitution? Let's learn what do you mean by exhibiting diminishing marginal rate of substitution. For the convex indifference curve, the MRS or the marginal rate of substitution, the slope of the indifference curve decreases in absolute value as we increase x1. Thus, the indifference curve exhibit a diminishing marginal rate of substitution. This means that the amount of good one that a person is willing to give up for an additional amount of good 2 increases, the amount of good 1 increases. Stated in this way, convexity of indifference curve seems very natural. It says that the more you have of one good, the more willing you are to give some of it up in exchange of other good. Now, the question asks us to the indifference curve we have drawn for Ambrose exhibit diminishing marginal rate of substitution or not. Now, Ambrose had two indifference curves which had the equation as x2 is equal to 20 minus 4 square root of x1, and in part C and D we calculated the slope of this indifference curve at the point 4, 12 and at point 9, 8. Slope at 4, 12 was minus 1 and slope at 9, 8 was minus 2 divided by 3. Also, Ambrose had another indifference curve which had the equation as x2 is equal to 24 minus 4 square root of x1, and in part E we calculated the slope of this indifference curve at point 9, 12 and at point 4, 16. At point 4, 16 the slope was minus 1 and at point 9, 12 the slope was minus 2 divided by 3. Now for the indifference curve to have a diminishing marginal rate of substitution, the slope should be decreasing in absolute value as we increase x1. So at point 4, 12 the slope is minus 1 and taking the absolute value of it becomes 1. And again at point 9, 8 your slope is minus 2 divided by 3 and taking the absolute value of it is 2 divided by 3. As I am increasing my consumption of good 1, my slope should be decreasing. So if you note here, Ambrose is increasing its consumption from 4 units to 9 units and its slope is decreasing from 1 to 2 divided by 3 in absolute values. So thus the slope is decreasing in absolute values as we increase x1, which means this indifference curve is exhibiting a diminishing marginal rate of substitution. Let's verify this graphically as well. Note that this was the indifference curve corresponding to this equation, and this is your point 4, 12 and this is your point 9, 8. This red line is your tangent at the point 4, 12 which tells us the slope of the indifference curve at that point, and this green line is the tangent at the point 9, 8. So if you note here that as I'm increasing my consumption of good 1 which is nuts, my tangents are becoming flatter. So this green line is flatter than this red line, which means my slope is decreasing. As flatter the line, lesser the slope. Thus, as the consumption of nuts or good 1 is increasing, your slope is decreasing, which you can see as your tangents are becoming flatter. Thus, this exhibits your diminishing marginal rate of substitution. Let's verify this for this indifference curve as well, which had the equation x2 is equal to 24 minus 4 square root of x1. Again, we have to take the absolute value of the slope. So taking the absolute value would be absolute value of this, which is 1, and absolute value of this is 2 divided by 3. Again, in order to have a diminishing marginal rate of substitution, my slope should be decreasing as I am increasing the consumption of good 1. Note here, as we are increasing the consumption of nuts, which is your good 1 in this case, from 4 units to 9 units, our slope is decreasing from 1 to 2 divided by 3 in absolute values, which means this indifference curve is also exhibiting diminishing marginal rate of substitution. So let's verify this graphically. Now this is the red indifference curve corresponding to this equation, and this is your point 4, 16 and this is your point 9, 12. This green line is the tangent corresponding to the point 4, 16 and this blue tangent is the tangent corresponding to the point 9, 12, which are telling us the slope of the indifference curve at these 2 points. Now note that as we are increasing the consumption of nuts from 4 units to 9 units, the tangents are becoming flatter, which means your blue tangent is flatter than the green tangent, which means your slope is decreasing as you are increasing the consumption of nuts. Hence, this indifference curve also exhibits a diminishing marginal rate of substitution. So the answer to this question is yes. The indifference curve we have drawn for Ambrose exhibits a diminishing marginal rate of substitution.